Folks, welcome to the episode 2 of the Cohesive Chemistry podcast, where I talk to some of the big names in the IB chemistry world and try and gain and share some insight from their experiences and their expertise. This week, I'm joined by Elisa Jimenez Grant. Elisa is currently working at the International School of Lausanne and has experienced it in nearly every possible facet of the IB chemistry ecosystem, including the roles of, and I'll try and do this in one breath, teacher, head of science, extended essay coordinator, senior examiner and moderator, curriculum review team member, workshop leader, site visitor, workshop and teacher support materials development team, program communities and IB exchange forum moderator, program leader, and Oxford University Press textbook author of the most recent edition. Elisa, welcome to the podcast.
Thank you, Ollie.
So Elisa, I think that there's enough experience on that list to fill probably an entire podcast series. So I'm going to try and do my best to focus on some of your insight that maybe is valuable to classroom teachers. But maybe we can start off. Could you tell me how you ended up becoming a teacher in the first place?
So I wasn't really ever interested in teaching. My thing when I was at school was always kind of environmental science. And so then, I went to university. I went to university in the States. I went to Bryn Mawr College, and I there they have, it's a liberal arts school. So I did a major in chemistry. And after that, so my plans were to go on and work in environmental stuff later on. And then at the time, my parents' health wasn't that great, so I ended up sort of going back to be near them and work. And at the time, I got a job in industry. I kind of realised that it wasn't my thing. I mean, I got quite involved with the education and training of the staff. It was a detergent plant. And got quite involved with education and training there. So then I thought, well, maybe that's more where I want to go, because that's the kind of thing that you can do, I guess, in your early 20s. So I did. I did an employment-based teaching qualification and loved it. But it was always kind of a temporary thing to me. I really enjoyed it. I've worked in IB schools the whole time, my entire career. And really, really enjoyed. I did the IB as a student as well, or the DP, strictly speaking. So it was very familiar to me in that sense. And being in school was something I really enjoyed. But it was always something that I was going to stop and go on to my original plan and do. So then I stopped teaching, did a full-time master's in environmental engineering at Imperial College, and there I really enjoyed the master's. However, I realised that I really missed teaching. So then I just went back into it, did a master's in education as well, and that's kind of how I got into teaching. I guess sort of a bit stop and start, I suppose, but got there in the end. And now that was in the early 2000s, so I've been doing this for a while, longer than I care to admit.
Yeah, a couple of years. And how come you ended up in chemistry specifically instead of maybe environmental sciences?
My first degree was in chemistry, and I guess when I went to university, my intention was to always focus on biology. Then I realised that all the biology that I loved was actually chemistry. And so I switched programs then, and it was cell membranes actually, a phospholipid bilayer that made me look twice at sort of chemistry as a career path, or at least as a focus. And then I ended up focusing on organic chemistry, like the synthetic organic chemistry route.
Can you remember from those early years some of your key learning as a chemistry teacher? I certainly remember from my experience, I don't think I was a particularly good teacher actually at that time. I worked really hard to try and get better, but it's a real steep learning curve. It was in my experience. Do you remember any of the key learning that kind of? Yeah,
definitely. I mean, in terms of, I made so many mistakes. I still think back to some of my lessons and think, oh, that was awful. But in terms of what was best for my development, I think of the things that were kind of really important then that have either persisted or evolved in my practice over the course of my career. I think I had an amazing head of department there, and I remember my first batch of IAs. The IA system was different then.
Yeah.
I don't know how, maybe you're familiar with that, the complete, partial, not at all kind of system where we put together a portfolio and sent over the best of two.
Yeah, that was choosing from the different sections of an IA.
Yeah.
You could choose 2 bits from each. Yeah.
Yeah, exactly. So that's how the IA worked at the time. And he basically sat down. I mean, it's really collaborative, not in the sense that, he said, well, let's see how you marked this and I'll tell you what I think. We actually sat down together and worked through my entire sample. I mean, I'm not saying heads of department everywhere should be doing this at all, but it's just in my experience, this is how he went about it. And so we went through my sample, and it must have been earlier than the sample, actually. Anyway, at some point, we sat in a coffee shop and went through every single one. I had a very small cohort of their portfolios, and we kind of co-marked them. And I do this in workshops now. I'll pair up, if I have teachers with varying degrees of experience, I'll pair them up together and then get them to, or ask them to go through the piece of work and kind of narrate their thinking.
Yeah.
And you hear a lot of that nowadays when people talk about, people using visualizers and document cameras and things like that, how you should make it really obvious to the students what your thought process is when you're going through a question. So it was the same sort of thing, except it was marking an IA. And that really kind of it made me feel really confident. It made me feel, I mean, I was then invited a couple of years later, I was invited to become a moderator at the time, once I sent off my sample. So, one of the key learning things for me was having an amazing set of mentors in that first program that I did, because like I said, it was employment based. So I really had to hit the ground running, and I had someone that who was in my classroom all the time. It seemed anyway. Giving me feedback all the time, but then also these sort of truly collaborative tasks that really got me thinking, or at least encouraged me to think about things that a novice teacher might not think about. So that was one of the big things for me, that environment. And the best advice I got in that environment, which has then kind of evolved, was to think about, I'm sure this isn't unique to me or the mentor I had, but to think about what the students are doing, not what I'm doing. And that over time, what's been interesting was sort of reflecting on how that's changed. So now then later I kind of thought about, okay, not what are they doing, but what are they thinking about, knowing that, attention is kind of like a gatekeeper to learning. And then more recently, I've been trying to focus on how hard are they thinking about whatever they're thinking about, this idea of ratio. So that idea of what are the students doing, what are the students thinking, and how hard are they thinking, and sort of seeding that at the very beginning of my career with an idea of, because at the beginning of your career, you're sort of focused on what are you doing?
Totally.
And what am I going to do next? And it really to focus on the students and their thought processes was helpful.
Yeah, and I think that's something, I guess, comes with experience, doesn't it? Because at the beginning, like you said, you are so focused on what you are doing, what you're going to explain next, how you're going to set up a practical or whatever.
Yep.
You don't really have the mental space to be thinking, okay, what are they actually thinking and doing right now? How can I check that they're understanding what I want them to understand?
Exactly.
It took me certainly a few years before I was in that place where I had that mental space during a class to be fully trying to engage with students and what they were doing and how they were thinking, which is kind of interesting. And I think go ahead.
Go on.
Please.
I was just going to say that at the time, that's when William and Black's Insight, was it called Inside the Black Box? The formative assessment book came out, and maybe it had come out a little bit before. Anyway, so it was very much kind of, I think nowadays we're very, with cognitive science and all of that, we think, okay, this is what students, we think about feedback and what are they thinking. But at the time, or at least for me, it was, completely new. So you're right, it comes with experience, isn't it?
You have to focus on yourself to start with, And then once you get the hang of what you're doing, then you need to start kind of placing your attention elsewhere. But
exactly.
definitely it takes time. Do
Yep.
you have any good failures or failure stories from those early days that you maybe learned from?
I don't know if there are any good. I mean, I thought about this one, but the one that I go back to, and I still think, oh, cringe, was a PSHE lesson, because I taught PSHE my first year, on sexually transmitted diseases.
Right.
And so my lesson plan, this is really, I don't know, I just think now, I think, what was I thinking? Anyway, was to just create this like huge table on the board and summarize it all for them. And at one point, one of the students was like, do we have to know this? Like, what do you want us to do with this stuff?
Yeah.
They were sat there quietly, so I just figured they were listening and learning. So it really kind of hit home when I first heard that phrase, or that saying. It's just because I taught them doesn't mean just because I taught it doesn't mean they learnt it.
Yeah.
Or whatever it is. So I don't know. It's not a very kind of big example, but I'm sure that there were lots of moments like that when I was just so concerned about what I was doing and that the students were going to run out of things to do, that I taught many a terrible lesson.
Ditto. I mean, that's I remember from the first IB school I taught at was in the south of Spain. I remember kind of reading textbooks the day or on the day of a lesson, and then kind of regurgitating, just writing all of this information on the board. They're all copying it down. Okay, right, I've done that. Move on to the next bit with no real, like, have they got anything from that, or are they just writing stuff that I'm writing on the board?
Yeah, exactly.
Lots of moments like that. And in hindsight, you think, really wasn't doing a particularly good job. But I guess, you have to start somewhere and just hope that learning curve moves quickly away from those moments.
Yeah, and I guess I was also really fearful of students not, like, them running out of things to do. So I was always producing, another piece of work and another piece of work. And now I really try and kind of get as much bang for my buck as I can,
Yeah.
And my DP students, I give them a chemistry Olympiad paper, and they sit with it, and that's what they go to if they run out of things to do. But they never run out of things to do.
Yeah, that's something I found. I've made an effort this year to really think about kind of extension tasks, I guess would be the word. But actually, with the pace of the course as it is, even the keenest students, I want them to just really solidify their understanding and the specifics of the content. And there's not that much extra space. I mean, beyond the classroom, sure, if they can find the time, which really is difficult in a course as busy as the diploma program.
Yes.
But it's interesting to know.
Yeah.
Okay, yeah. So a couple of the big experiences I want to pick apart a little bit. First of all, maybe you became a senior examiner at some point. Something, again, I've never done. I want to dive into that a little bit. For example, what are the common kind of the pitfalls for students that you maybe see when you're marking hundreds of papers a year?
What's interesting is that it's not that different from what you see in your classroom a lot of the time. So it's very unusual for me to find a lot of papers that have a kind of consistent mistake or something that I haven't seen myself in my classroom at some point. Once upon a time, there was something to do with global warming on one of the papers, and I remember thinking, we need to really think about explicitly teaching the greenhouse effect and the enhanced greenhouse effect and climate change and so on properly, because there was I think they were mixing up ozone and carbon dioxide. I can't remember the ozone layer. That was one year in particular, and I've always, I guess, with my academic background, I've always made sure that that's kind of really, really clear. But that was one of the times that I thought, this is something we really need to work on, which is why I'm pleased that in the new curriculum, this used to be part of option C, and now it's in the main. Well, everything's there's no option, so now everybody's going to do this, so that's good. But no, in terms of the mistakes or the pitfalls that I see, that are general, things like lack of clarity, a lot of waffle. Sometimes some students use additional sheets, which they're welcome to use, So examiners read everything, right?
Yeah.
And nobody thinks, oh, this one's got 77 additional sheets. Well, maybe 77, but you read them, but sometimes I just feel really badly for some of the students who feel like they're writing a lot, but they're not actually saying very much.
Yeah.
And so that's something that's quite common. The flip side is that, I'm always, every exam session, I'm always impressed with students who just lay out their calculations beautifully. They'll draft, you can see that because you see all the sheets, you can see that they've drafted some of their answers, or even the structure, even if it's a 3-mark explanation. If you go back to the additional sheets, you can see that they might have done some kind of skeleton for their longer answer and stuff. So there's students who do have those kinds of, I guess, their ATL skills to help them. But there are students who don't. Things like messy calculations, start writing right in the middle of the box and then sort of write the calculations all around it and in the margin. And again, I mean, as an examiner, you know what to look for. You get really good at interpreting and deciphering handwriting, but it doesn't show like clarity of thought, I suppose, which is what the really top achieving students are getting.
Yeah.
Things like not reading the question, especially with database questions where there's bits of information that might have been on a different page or in a prior section of the question that they haven't picked up. So those are kind of general pitfalls, and then specific errors that look out that students kind of often make that I think students everywhere should look out for are things like confusing. I mean, the big one for me is the confusion between what exactly happens when a molecular substance vaporizes. Covalent bonds don't break. You do not break oxygen hydrogen single bonds when you put the kettle on. And then year in year out there are answers where that's kind of, it's not necessarily at the forefront of a question, so teachers don't necessarily address it, but it's sometimes in the underlying subtext in questions, particularly about intermolecular forces. Right? Things like saying ionic molecule, things like that show that there isn't a very good understanding of structure and bonding, I find is quite common. Another thing, this is very specific now, in calculations, what to plug in as a mass can be very complicated for them to understand. In calorimetry calculations, concentration formulas. I'm sure this isn't unique. I'm sure you've seen some of these things in your students' work sometimes.
Of course, yeah.
Yeah, so it's very, it's nothing kind of surprising. Things like connectivity errors, if you've got an organic structure and there's a functional group that's attached to it, then not being very explicit about where that bond is, that bond is between the carbon and the oxygen and the hydroxyl group, for example.
Okay, right.
Between the carbon and the hydrogen, or somewhere in between the oxygen and the hydrogen. Same thing for curly arrow mechanisms and things like that. So that kind of deliberate, very specific placement of those types of things can be really tricky for them. And then this, which is a common issue across, I think, all levels of chemistry, is saying that atoms want things, and they want to have a full outer shell, they don't want to move, and neon has a really high ionization energy because it wants to have a full outer shell and it doesn't want to lose it. So yeah, those are the kind of main things. Are there any other things that you can think of that you might have come across in your career, perhaps?
I think actually those ones that you've mentioned already, which is something that they're quite foundational understandings, but it's very easy to kind of browse over them or assume that students have picked up on that. Like I was talking about when we're melting or boiling water, what do we break? Are we breaking bonds, or are we overcoming intermolecular forces? That's something that I kind of in the last few years have really spent a bit of time on, because it makes a big difference to their conceptual understanding and all the subsequent understandings that they come across.
Yeah, and exactly.
Take water and diamond. Well, what am I actually having? Which particles am I having to separate here? Is it atoms? Is it molecules? What forces am I overcoming? So I think you mentioned those, and the calorimetry one, the sticking in the mass of something that's not relevant to the water that they're heating. Yeah. I think those are really important ones, and they're really foundational and easy to skip over. So actually, I think it's helpful to remind ourselves, or teachers in general, sometimes those baseline concepts are actually quite important to make sure students understand before you move into more complexity. I'm trying to think of any others. I mean, calculations is an interesting one. What about like units? Should they always use units at the end of each part of a calculation? Is that helpful? Does it matter?
So this is an interesting one, because it used to be that they had to, and they'd lose a mark for incorrect units and another mark for incorrect significant figures per paper, right? So if the whole paper was rounded to 4 sig figs or whatever, then they'd lose 1 mark. But now it's different. Now there's usually, I don't know what it's going to be like specifically with the new curriculum, but nowadays there's usually one question that says, what is the entropy change in joules per Kelvin mole or whatever of blah blah. So it kind of very specifically asks for the unit, or it says something like calculate the relative atomic mass of blah blah, give your answer to 2 decimal places, or using the correct significant figures, figure this out. So usually now there's one very specific question that asks for this. Right. That said, what I do is it's interesting as an examiner, I perhaps aren't as harsh as I am with my students on this. I mean, with my students, I still take off a mark for missing units, and I still take off a mark for significant figures per paper, just so they don't have to. It's just one less thing for them to think about when they're doing the real exam. If they're just kind of drilled into thinking that and they've had plenty of practice. But I, as an examiner, I find myself, if they're calculating a delta G and they don't have to give it to a certain number of significant figures, then they can give it to, they can write down the whole calculator.
Full calculator worth.
Yeah, exactly. Yeah.
And if the question asks for specific units, do they still need to write the units to get, or is that implied from the question?
Oh, I get it. Yeah, no, I didn't understand. Yeah. Sorry, I misunderstood that. I can't. You know what? I think if the question says give it in joules and they give the correct number but don't state the unit, I want to say that it's not always required, but it might just depend on the exam session. Sometimes, this is an interesting thing that lots of new examiners don't always realize, is sometimes there's a bit of ambiguity in how to apply the mark scheme, which is amazing to me. I mean, I don't know how people mark things like, well, you know better about TOK than I do, but, things like TOK essays and, literature essays, because when you mark an exam paper in chemistry, you'd think there's very little room for discussion.
Yeah, of course.
And there is sometimes. And sometimes, the principal examiner will say, okay, we're going to mark this question like this. And it's almost like it's just for the sake of consistency. Because then, a grade award, any different, which is the final process of the exam marking process, any exceedingly harsh or exceedingly lenient marking expectations will be ironed out. But in the marking process, it's really important that everybody marks consistently to the same standard. So that's sometimes where they might say they have to give the unit or not. I can't think of a concrete example when they have done, but I wouldn't be surprised if they did. Let's put it that way.
Yeah, it's interesting. The same every time I grade a set of tests and give them back and think, right, I've done that objectively done. There's always a couple of kids. Well, I thought I said this here, and you're like, well, yeah, actually, you kind of did. Where is that enough? Nothing is really totally objective, I guess. And you're right. TOK is more difficult, as I'm sure English and whatever it might be as well. But the other little kind of nitty gritty question, the benefit of doubt mark, BOD, does that apply to those kind of questions where they've communicated enough to show that they've understood it, or is there a different context for using that?
I try not to use BOD very much in my teaching. If I do, it kind of signals that a student needs to have a discussion with me about a specific. It's almost like a good enough answer. I'm going to give you the mark because I have to, but I don't really want to, because we need to make sure we iron out something. Whereas I use it very differently again when I'm teaching than when I'm examining. When examiners don't use BOD that much in exam marking. Right. Perhaps sometimes you see it a bit more in IA moderation, but things like I mentioned handwriting earlier. It could be a 4, it could be a 1, it could be a 9.
Okay.
Let's just give them the benefit of the doubt. Or you sort of look at a different question that's also a number crunching question. You say, okay, well, here, this is obviously clearly a 4 and it looks similar, so I'm going to give them benefit of the doubt for this one. Things that could have been a bit faintly scanned sometimes.
Yeah.
Things like Lewis formulas and things like that, perhaps. Often, and this is an interesting one, because students really struggle with this, the ones who want to write everything they know, if there's a contradiction in the answer. So if they say they answer something properly and then later on they go and say something that contradicts that, they do risk losing that mark. Again, depending on the specific case, or in some cases you might use BOD if it's not completely clear. What I usually say to students is, because we can't give any half marks, we can't say, okay, you can have half got it right. That's if you were to give a 0.7 of a mark, that's when I would start giving a BOD mark, for example.
Okay, you're kind of rounding up from the...
Yeah, exactly. Yes. That maybe makes it a bit more concrete.
Yeah, interesting. I guess there's another thing related to that again. Sorry, this is right into the nitty gritty. If something asks you to state 2 things about whatever it might be, and they put 3 things and 2 of them are right and 1 of them's wrong, how does that work? I'm not familiar with it. Is that I'm
going to be really annoying and I'm going to say it depends.
Okay, yeah, fair enough.
But if it depends, if it's like a short, there's something called a list principle or a list rule, which is that if they start writing a list, so if they ask, I don't know, it's an IR spectrum and they have to give the bonds that are present or something, and they give 5, but the question asks for 2, then you don't know that they're not just writing all the ones they know, and they're trying to hope that one of them's right. So you take a mark off for each incorrect one.
Right.
In that case, in the whole list. Sometimes if it's more of a like explanation type question and they have to give 3 reasons, and they give, or maybe they have to give 2 reasons and they give 3, and one of them's kind of a moot point, but the other 2 are fine, then they don't get marks taken off. So it really does depend a little bit on the question and the context of the question. The IA is a good example of that, though. I guess the IA is not marked with marks, and we'll probably talk about it later, so I'll leave that.
Yeah, sure. Well, I mean, that's a good segue into the IA, perhaps, is it? Thanks for doing that for me.
There we go.
You've been an IA moderator and team leader in that context as well. Yeah. What kind of things do you notice are recurring themes there, be it pitfalls or strengths and things to look out for?
Okay, so if we sort of work through the report in the beginning, especially now that we still, in this exam session and in November, we still have personal engagement. So you have students who claim to have always been fascinated by a particular equilibrium system, for example. So that kind of artificial personal engagement is a common pitfall. I mean, at the moment, nobody takes marks off for somebody saying that. You look for personal engagement. You're supposed to mark the whole report and look for evidence of personal engagement elsewhere. It could be creativity in the design or the analysis or creativity in finding solutions and troubleshooting. You look for it. It is very self-evident when a student's truly kind of invested, I think. But that is a common pitfall, thinking that because it's the first criterion too, that it's the first paragraph is a little spiel about something, and that uses up the space. Currently it's pages. Later on it will be words, so it's even worse if they do it, because it's just words that don't count for anything. Go on. Sorry.
I imagine it sets a little bit of doubt in the mind of the moderator if you're getting that kind of, my grandfather took me to the woods and taught me about aspirin. It just kind of plants a seed of like, okay, they've not maybe quite got this, so it's a bit of a dangerous way to start. But yeah, I mean, they're quite funny at times. But
I think that as a moderator and examiner, you really, I mean, obviously nobody can be 100% objective ever.
Of course.
You try to kind of give merit where merit is due, and if someone's got, like I said, if they write loads of extra pages, or if they have really poor handwriting, or if they, in the IA, for example, if they've got a section that's not particularly, that evidences that they don't necessarily need, that they don't really understand the purpose of the background information. That's the issue, isn't it?
Yeah.
It's that justifying the rationale for the research question is not one's own personal memories. It should be something that's grounded in science. And that takes me to the next sort of common pitfall, which is the background information is really difficult to write. And I still find it difficult to kind of articulate to my students exactly what we're looking for there. I always say you've got to justify the research question and the choice of variables, and why is this an interesting thing to investigate?
Yeah.
And for them, they might think that they're justifying it by saying, when I was little, my grandfather took me to the woods, and so on. So it's one of those things where you really have to sort of think about how they understand the command term justify or explain or whatever.
Yeah.
So that's the first bit. I always tell them to write the background information at the end.
Okay. Yeah. Interesting. Yeah.
So I tell them to give me when I'm approving an IA, then I'll ask them to write a few bullet points of why they're doing that one, why that reaction, why those variables, why that range, why that number of trials, etc. But then I'm like, forget about this and let's come back to it later.
Okay.
For example, it's a good place where they can explain sort of nuances in their method that don't come across in their research question and so on. The other common pitfall is because students very often write a separate variables method and then materials and method, which is fine. I mean, I ask mine to do that very often too. But sometimes they identify all these control variables, and they might even be really important ones, but then that's not reflected in the materials or in the method. So they'll say, I'm going to make sure that I control temperature, and they might even say they'll use a water bath and a thermometer rather than an air-conditioned temperature-controlled room or whatever. And then there's no mention of a thermometer or a water bath in the materials list or the procedure or anywhere else in the report. So that's another area that could lack kind of consistency. That often lacks consistency.
Yeah.
It's sort of the variable control being reflected throughout the procedure, and also in the data collection possibly.
Yeah, I think that, and I've heard a few cases where students have kind of incriminated themselves by including a photo of their setup, which doesn't have any of the kind of aforementioned controls, which kind of solidifies in the mind of whoever's grading it. Right, okay, so you probably didn't actually monitor temperature. There's no monitoring of it in the data, like you said. It's kind of a little bit self-defeating. But that's a really interesting point. If you say you're going to control something, hey, control it. And if you're monitoring the temperature in the lab at the time, make sure in the data section you've got some evidence for having done that.
Yeah, there's two things that students need to make sure they have present in their mind at all times. One is obviously the research question, the way it's written. So if they say rate, then they should be calculating a rate or a relative rate and talking about rate, not time, for example. But so one is the research question, and the other one is like you said, variable control and the evidence of that variable control later on. And that comes through later as well. I mean, I think that if they write qualitative observations that say things that are not related to the fairness or the reliability of the investigation, then are they really kind of relevant? And now that we're looking at, working with word counts, that's going to become more important as well.
Yeah, not burning words there.
Yeah. What else do I see? So this thing about sufficient relevant data can be really difficult. We were actually talking about it as a department the other day, because we're trying to make it so we can't just say it's got to be 5 independent variable values. Sometimes people call them settings. So 5 settings, 3 repeats or 3 trials. That's it. And if you're doing a standard deviation, you should do 5 by 5. It really depends on the experiment. And I think that, I think it's good for students to start with that 5 times 3. But then it's really up to them when they do the IA to question and to justify and address the need for sufficient relevant data, and whether the data they've collected is sufficient and also relevant.
Yeah, and I guess that's something for teachers to be aware of when students are starting their data collection, just keeping an eye on, is it sufficient? Is it relevant? Do they need maybe a bit more? Is it, that's definitely worth bearing in mind as a teacher.
Actually. Yeah, sort of thinking about the mechanics of the IA. It might be too late afterwards, I just need to let the cat out.
Yeah, please do. I'm going to try and turn this lights.
Okay.
I'm glad it's your cat and not my son running into the room.
photobombing our podcast. Okay, so that's a section that can be cut out, I suppose. Anyway.
Yes, yeah. Just trying to say, I realised the light on my face. I was getting paler and paler as the sun sets outside.
Okay. Of course, because it's sunset here. It's been dark for ages. Right. So other common pitfalls in the IA is I find, and this is going to be really interesting, the new criteria, that they spend so much time designing their experiment and thinking about it and understanding it and then processing the data from it, that when they get to the conclusion and particularly the evaluation, it's like they're intellectually exhausted. It's like their brain's empty, and they end up writing a really superficial evaluation with lots of generic sources of error that aren't necessarily evidenced in the data, be it the observations or the numerical data. And now that the evaluation is worth 25% of the grade, and then the conclusion is worth another 25%, that's going to be really important. I've been thinking about that one, actually. I used to stagger my IA deadlines for the first draft. I used to say, right, on blah blah, on next date you've got to hand in your design exploration, right?
Yeah.
And then I'd have a look at it, give them feedback on it, and then at a later date they'd have to do the analysis, and at a later date they'd have to do what was called evaluation, or is called evaluation in the legacy curriculum, to give them a chance to kind of focus on one thing at a time. And it's got its pros and cons, but it might be something to think about as we move towards. There's a question on the program communities at the moment actually about IA and what do we have to change to address this new weighting for conclusion and evaluation. But evaluations are very difficult for them to do. If they don't understand what they're doing and they don't understand the chemistry behind it, it's really difficult for them to do an evaluation properly.
Yeah, and I think that strategy is actually not something that's I've ever thought of before, but by doing it piece by piece, they're getting some kind of solidity in the sections they're doing as they go. So actually they avoid that intellectual burnout that you mentioned that I think is really evident when they submit their drafts. Yeah. And it just gives them a bit of space, and it also means that when they get to their data analysis, if the kind of research design section is atrocious, if they've had feedback on that first section, it gives them time to think about, okay, what consequences does that have on how I'm processing my data or whatever, which is kind of interesting. I guess that the downside is potentially time for the teacher in that process. But I'm sure you're extremely organized. If you can find a system to make that work, that's kind of an interesting idea.
It is. I mean, I stopped doing it because of the time. I used to do the IA in the first year, and that gave me enough time to do whatever I wanted. Now I don't, and that's one reason. The other one is just because we only give them feedback once. Yeah. And because there might be something in the design section that then you didn't give feedback on at the beginning, in the first chunk, after the first deadline, because it wasn't relevant. But then you realize later on when they've written their conclusion evaluation that there's an issue, then it's, you just have to be really careful to make sure that you're not giving feedback on anything more than once.
Yes.
So that's something that's just a little bit like, need to make sure I do it properly. And there was something else I was going to say about the evaluation. Oh, I know what it was. This is more from when I was extended essay coordinator. I'm not currently, but when I was, it suddenly dawned on me, and this is probably something that other people have realized, not me. It dawned on me that students don't realize that writing one of these reports is not a linear process. So they think you write the research question, and then you don't touch it again, and then you keep going, and then you do your analysis, and then you're like, okay, well, I'm stuck with that graph, and then I have to do it. So they don't understand that it's iterative. And there was something recently in a magazine, I think it might have been Chemistry World magazine, not it was one of the RSC magazines, which was advice on writing a PhD thesis that made me think about it, because it said, write the advice for a PhD thesis for someone writing a PhD thesis was write the section that you feel most comfortable or most confident about first. And I was like, oh, I'm totally gonna pinch that, because I think that's where they can really kind of, because they're still building their understanding of what they've done and the chemistry behind it. If they start with the background information, it's going to get really complicated for them really, really quickly. Whereas if they start with, okay, this is what I did, this is the data I collected, I don't know, I'm going to plot a graph because that's what I'm probably better, so I've had most practice doing.
Yeah.
Then let's start with that.
Yeah, that's quite interesting. I guess the EE is particularly kind of relevant to that idea because it can be a little bit more wide-reaching, a little bit more exploratory compared to an IA, which is maybe a little bit of a kind of a tighter package. And I've got a couple of EE students at the moment who are kind of in the middle of collecting data, and I think that's actually quite a nice idea, because sometimes they get their data and maybe they then go back to the research question and think, oh, actually, it's not quite that. The graph I can produce from this data is not quite what I was originally thinking. So that iterative kind of tweaking of stuff as they go is quite a nice idea, and certainly letting students know that that's something that they can do. I think they often start, once they've got it, it's like, right, that's it. Now I can't change anything. I'm just gonna have to make the best of whatever I collect and write.
I know. Yeah. And I think that's a missed opportunity, because I think we kind of take it for granted, having written umpteen different papers throughout our education. We just think, well, this is how I do it and that's how everybody else does it. But I don't think they do. I mean, this is just a complete, I'm completely basing this on my observations. I have no idea if it is actually how they think about these things, but that's definitely how I think they approach these things, especially. And then when you give them feedback on the draft, then they'll go back and work really hard on the feedback on the first half of the report, but then they run out of time or whatever, and then they can't necessarily apply as much feedback where it matters most and where it can be most impactful. So when giving feedback, I do say these are the top 3 things you have to do. Yeah. And these are the top 3 things you have to do. And there's the first thing you have to do when you go back and write start writing your final draft. Don't start with, is my formatting, blah, blah, or,
font size 12. Okay, that's perfect.
How do I get this table to be presented horizontally, and that sort of thing.
Yeah. I wonder that's kind of a good point. And I wonder how your feedback looks on that draft. I think certainly for me, however it's done, comments and whatever, the 3 key points for improvement is really helpful. Like you said, to direct them right. If you do nothing else, here's 3 things that really need attention. Yeah. To produce a decent piece of work.
And to sort of say, okay, if you've, and it's the same with revision, if you've got a student who's really kind of intuitively understands chemistry, and when faced with a new topic, gets it straight away. They can, for example, because I've just taught this, somebody who really understands the use of enthalpy of formation data and enthalpy of combustion data, and really understands how to use that and how it applies, how it's a Hess's law application, rather than is it products minus reactants or reactants minus products.
Yeah.
Then the feedback you'd give them is probably going to be different to the feedback that you'd give a student who might be making that mistake when the one we were talking about earlier about plugging in the wrong mass data, for example, in a calorimetry experiment. So sort of really making sure that the feedback is targeted and actionable by the student that you're giving it to. And then to say, once you've ironed all of this out, then you can worry about this sort of higher level thinking stuff, for example. In terms of feedback, I think so I try to, I don't know if it's like the top 3 things or maybe one thing for criterion that they have to improve on. And obviously all the academic integrity stuff, if they haven't got proper referencing in there and so on, that's always a really, it's the same for the extended essay, they have to do it. It's no longer, because I don't know about your school, but mine do the MYP before doing the DP, and documenting sources properly is in one of the assessment criteria in MYP sciences.
Right.
So they're kind of used to doing it for a grade or for a part of the mark. And when it comes to the IA, it's expected and required but it's not necessarily doesn't necessarily translate into points.
Yeah, and I think that problem maybe has been amplified by AI, and these kind of this year are the first ones who really have just 1,000 different AI tools that have varying degrees of that's totally not your work. Oh, that's just helping the English. So that's interesting. I think maybe the MYP is a good start point before the DP if they're pretty well drilled in just referencing, for example. Like I know a lot of students I teach, referencing is a bit of a new idea when they start the IB diploma program. And I take for granted how obvious it is to use. And then I'm surprised when there's just nothing referenced and students actually aren't really sure.
Yeah.
What do you mean reference? What does that even mean, really?
And that's extra cognitive load for them, isn't it? To kind of remember to put all of that in.
Yeah, definitely.
Yeah.
I wonder, kind of related to that and the feedback, as a moderator, how useful is the kind of annotated work that we submit in the moderation sample?
It's very useful. I've moderated work that has nothing written on it, that's presented beautifully. Sometimes, you used to, before we went online, you used to be sent these big things through DHL, these big sets of IA samples, and they'd be beautiful pieces of work presented, and there wouldn't be a single mark on them, not a pencil mark, nothing. And I think it's important for teachers to remember. It was different over the last couple of years because of the pandemic, but in principle, moderators are not, they're not primary markers, they're moderating, and so it helps. First of all, teacher annotations help moderators find. So if I see a page full of calculations, for example, and then there's a teacher comment that says these are correct, and then I go through and check them and they're not, that tells me something about how the teacher's interpreting the criteria. Yeah. And that then means that the feedback I can give can be very specific. And it's also, not to mention that it's helpful if someone picks out, and if teachers pick out mistakes in calculations or whatever, so you don't have to go and find them yourself.
Sure.
But I think, as much as I find when I'm annotating that I make comments that say what has been achieved and what hasn't been achieved. Like, what is the evidence of achievement of, let's take sufficient relevant data as an example, and what isn't. And that helps me award a mark as well. Yeah. Just writing it. And I don't write it extensively as if it were an IA that's going off as a sample. I just usually use a separate sheet. I've got a sheet that I share in workshops, but it's nothing special. It's just a table, a blank table that's got the criteria down the side, and then the kind of sub boxes, little boxes, but one for each strand. Yeah. So then you've got, research question, context or background information, and so on, and then safety at the bottom for the current criteria. And that just helps me if I sort of look at each. So if I'm looking at a student IA, then I can write 2 or 3 things just by hand in really messy handwriting. It's just for me to see what they have done and what they haven't done to better apply the best fit model. Because otherwise, I feel like there are errors, that there are things that haven't been achieved that kind of stand out too much to me, or things that have been achieved, especially when it's your student and you know how far they've come. Yeah. It's so easy to be super biased and say, but, I know where they were at the beginning of this process and look at what they can do now without necessarily paying as much attention to what they haven't done. So that helps me then award a mark for each strand. Yeah. And I suppose in the teacher annotation, when you're justifying what they have or haven't done for the moderator, it presumably is helpful to use language from the actual criteria. That's themselves. A really good question. Yeah, that's a really good question, because that could be interpreted as saying, just take out the strand, copy and paste it in, right? So if it says they've partially or outlined or described rather than explained, and you just copy and paste that strand in or that descriptor and put it in, then that doesn't add value. But if you say this is described and not explained because there's no underlying reason, and explain means giving the reasons or causes, then that's helpful. Okay, you're showing thinking, but in relation to the criteria as opposed to copy pasting. Yeah, it's because sometimes people interpret annotations as saying, well, here is where they've collected sufficient relevant data. But what I want to know is how do I know, or how do they know that it's sufficient and relevant data in this context? It's difficult to do that concisely. So sometimes it's best just to put it on a separate sheet if it's a big issue.
Yeah, makes sense.
I also do things when I'm annotating, like saying, I've already penalized this here, so I'm not going to double penalize it here, just to sort of say, I am aware of this error, but it's already been, it's already been marked down up there, so I'm not going to mark it down again.
Yeah. So you're making it as easy as possible for the moderator to see that you've thought about what's going on, and in those kind of cases, I think I can imagine that's really helpful. Look, I have already noticed this. It's already been penalised, but look, on this occasion, it's not going to get penalised because it's already been.
I'll also do things if I know it's something quite contentious. I can't think of an example right now, but if it's, I'll quote a subject report sometimes. I'll say, I know that subject report X said that, this is a bad example, I can't think of a better one, but I'll try. That the combustion of primary alcohols isn't a good IA to do because it's self-evident and everybody knows it. However, this student has done this differently because, to sort of just make sure that, because moderators are looking at lots and lots and lots of these, to make sure that they just don't, their first impression isn't, another primary alcohols IA.
Yeah. Interesting. I wonder, maybe a final bit on the IA. I'm just interested in how you and in your school, how you approach it, structure it. Sounds like you do it in the second year of the course. Do you start early and break it up over a long time? Do you kind of crush it into a couple of days off timetable? How does it look for you?
Well, I'm new to the school I'm in right now, so I've currently got a cohort of DP1s. I actually don't have DP2s, as a new teacher new to the school. But I think it really depends, Ollie, and I think that's where it can be. You can really see the perks of doing it in lots of different ways, but those different ways don't necessarily work in every single context. So, for example, my current students, for the most part, we have students coming in all the time, as I'm sure you do, because we're international schools, but they do the MYP prior to doing the DP. So they're used to writing a lab report, because that's two of the four MYP criteria involve data, designing and processing and analyzing and evaluating experimental data.
Yeah.
So I don't have to scaffold that as much into my teaching now as I did before. So I've taught in schools that my previous school does, all students do IGCSEs. So then there are advantages there to the content that they might know, but the way they approach a lab report is very different, because they've rarely had to write a whole thing. They've written different sections, for example. So that's the main thing that I think about when planning an IA program. Okay, where do they come from, and how well do they know how to read rubrics, understand criteria, things like that. And then I try to do the IA as early as possible.
Yeah.
But nowadays that usually means sometime in the early in DP1, which isn't early in DP2.
Yeah.
Because it isn't ideal, because they've got so many other things going on at the time. So to counter that, I just try to spread it out as much as possible. I really try to get them to think of possible ideas, couple concrete possible ideas before the summer.
Right.
And then we develop them a bit further at the beginning of DP2. And then they pick one, and then the other thing is that in my current school, and I've never done this before, is it's that they're taken off timetable for a day. I think it's a day to do the IA data collection. And that's always, that fills me with dread, because I think, okay, well, I've got to make sure that none of it is dead time, and they don't spend the entire day trying to figure out how to make a standard solution, So what my plan is to get them to do some of that preliminary work in class, so that the day that they're collecting their data, they know exactly what their experiment's going to be.
Yeah, that's interesting.
Yeah. I don't know how you do it.
Yeah, in fact, my current school and my previous school my current school has 4 days off timetable, because most students actually that I teach do 2 sciences, so they effectively get 2 days per subject. But you're right, it puts a little bit of pressure on starting early so that they can iron out any possible issues, and then in those 2 days they can just pure do the data collection.
Yes.
But well, for my entire career, every year I'm like, right, I'm going to start planning this earlier. Inevitably, I don't start planning it as early as I want, and it always feels kind of rushed, particularly if you've got those 1 or 2 days where you have to kind of get it done. Otherwise, it's going to spill over into all sorts of other time. But I'm trying this year. We do our IAs at the end of year 1, so we're doing it in a month.
Ah, cool.
So next week is the start of my getting ahead of the game. Let's think about it. Let's try and find some research questions and start, ordering the stuff that we might need for the technician can help us out, and trying to get ahead of the game to take a bit of pressure off those 2 days. And I've got 21 students in 2 classes this year. And obviously if you're the only teacher of a particular cohort, there's a lot, 21 kids, there's a lot going on.
Yeah.
But actually, interestingly, when I spoke to James Midgley in the first episode of the podcast, who is big into exploring kind of simulations, databases, modeling software, and he's quite a big advocate. And I'm trying to shift a bit more towards this of finding some of those kind of secondary data IAs, which takes a bit of pressure off the lab. There's lots of good software out there which can still produce really high quality IAs. So I'm also mindful of trying to suggest to those kids who maybe aren't particularly interested in doing something practical, trying to find some options there and just reduce the pressure. It means that actually they can be collecting that data whenever.
Yes.
And takes the pressure off the actual couple of days in the lab when it's just kind of carnage for 48 hours.
It is. It's really hard, isn't it? Yeah. Those are useful tips. Well, I might reach out for further tips when I get closer to our IA day. Things, pitfalls and do's and don'ts and things like that.
Yeah, I'll let you know. I mean, we'll see how it goes. But there are kind of other options I'm trying to explore for the reasons I mentioned. Okay, I'm conscious we're getting close to about an hour. So let's maybe finish off with one question about your experience as the kind of forum moderator on the program communities forum. What kind of things do you notice in there? I mean, must be a really interesting position. You are basically kind of seeing all of these questions from people in all sorts of different teaching contexts about the course.
It is, and I think it doesn't get as much use as it could. But both IB Exchange, and they're kind of both 2 parallel platforms at the minute. But in the program communities. I really enjoy it. And sometimes you get a question that's really straightforward. Where can I find, the requirements for font size and things like that? Because navigating and trying to figure out navigating my IB can be a bit complicated sometimes. Yeah. And I know where those things are. So that's very easy to kind of give help on. But sometimes people at the minute, there's a couple of really good ones to go ongoing. There's one on an electrochemistry one. And there was recently one on radicals and there was something else. It was bond enthalpy and radical formation. Anyway, some of these things you kind of look at them and you're like, yeah, well, obviously the answer is B because blah, blah, because of whatever reason. And then someone asks a question on the program communities and you think, oh yeah, I hadn't thought of it that way. I mean, there's one on my IB Exchange that about the data booklet data for carbon. And the melting point and boiling point data and what that means. And another one a few years ago had to do with polar protic and aprotic solvents in SN reactions. So there's I really enjoy picking out those little bits and really thinking about them. So that's always really great. And I think what's nice about IB Exchange is that it's a little bit easier to share resources. Kind of like on that. Were you familiar with the old OCC before we moved on to my IB?
Yeah, loosely speaking, yeah.
Okay. So on that was really there was a real teacher resource exchange there where you could just upload things and comment on them and so on. And that functionality has been built into IB Exchange. IB Exchange also has content made by IB teachers for the various different programs that's then curated by the IB. So it's so there's some really cool things there to see what people are doing, and that it's been sort of checked by the IB. But yeah, I really enjoy the program communities for the same reason that I enjoy workshop leading and collaborative work with any kind of colleague. I mean, even in a conversation like this, you always pick up little tips and ways of thinking about things that you haven't thought about before.
Yeah, definitely. And I think workshops, one of the big bonuses of them is meeting other people, talking through stuff, sharing things. That's one of the big kind of plus sides, as well as whatever the actual kind of directed professional learning is.
Yeah.
And actually something that kind of part of the reason I started this podcast to try and talk to people who have done lots of cool stuff and have expertise in areas that are nowhere near my expertise. It's really interesting on a personal level, whether or not anyone else listens to it. It's been super interesting to me for me to learn from.
Yeah, I think it's a great initiative.
Yeah, I mean, it's again the lighting in here. I've got some kind of like flashing prison light behind me now. I've turned off my lamp, so I've kind of disappeared into the shadows. So it's a work in progress, but we'll get there at some point. I wondered before we jump into some final little quick fire questions. Are there any other top tips or things that we haven't mentioned that you think might be valuable to, I guess, particularly new and inexperienced teachers? Is there anything that jumps to mind?
I guess thinking of the program communities, a lot of the time you get, and in workshops, you get people asking, do you think this IA question would work? Do you think this IA question would work? Things like that. And I think that my advice is to always go back to the rubric and to see because it's really hard. It's not, it depends on how the student approaches it. It depends on like I said earlier, you could have a very novel IA that has to do with the combustion of primary alcohols in some way or another, So it's important to kind of remember that although it's useful to be able to respond very quickly to whether a research question is a good idea or not, because that's essentially what you're doing with the students. Sometimes you can very often do really well with a very wide variety of research questions, or you could take a research question that has a lot of potential and not do a very good job.
Destroy it.
Yeah, a good research question doesn't a good IA make, I suppose. But I would always encourage people, if they're hesitating between marks and things, just go back to the rubric, because there's lots of, I wrote a guidance document that I shared on the OCC a long time ago, and I think it's on for the PRC now, program communities, sorry, not the PRC. And every time I write more stuff into it, it just becomes this really long document, and it makes it. I try to put everything I know about the IA into it, and now it's just there's so much in it. And sometimes just going and looking at the command term and looking at the rubric can be really, really helpful. So that would be a tip.
Yeah.
And then the other tip is thinking back to that first example I gave you of my first head of department sitting down with me and live marking those IAs with me. I think that's really what it takes, and that's what's valuable about the IA part of any workshop, sitting down and discussing a piece of work. So I would almost encourage, and this is where time needs to be allocated for people to do this, in meetings or professional development sessions, to sit down, and the task is to together read and comment on this IA. So and then there's samples on my IB now. If you read more than one language, you can download the ones in the other languages, because most of them are different.
Yeah.
And I would encourage people to do that. I think there's no quick fix to understanding the IA criteria, and nobody ever gets it 100. I don't get it. I get moderated down sometimes still.
Sure.
Which maybe a conversation for another time.
Sure, yeah, but it's helpful to know, right? Particularly if you're a new teacher. Just trying to find your feet. It's helpful to know that you, as someone who has huge experience in moderating IAs and all other aspects of the IB, you're still fluctuating in those moderations from time to time, which I think it's nice to know. Actually, I think for everyone, like nobody's constantly hitting perfect moderation, but that's
no.
Yeah, I think that's good to know. Okay, let's finish with a few quick fire questions.
Okay.
What's your most and least favourite topic to teach, and why?
Okay, my favourite one is easy. It's bonding. I love teaching. I don't know why. I think it's got to do with what we were talking about yesterday about misconceptions and so on. It comes at a point in the course when you've already reached a good pace. It's familiar to what students know before, but then it really blows their mind when you start covering some of the HL stuff. And Yeah, I really, really, really enjoy it. And I really enjoy now. I always used to use the bonding triangle. I never taught option A, but I always used to use the bonding triangle. Really pleased it's in the curriculum now. I definitely advocated for that in the curriculum review. So bonding, for sure.
Yeah.
My least favorite, the ones that are my least favorites are usually the ones that I can't quite work out how to teach. One of them is gas laws. I think they're really interesting. I can explain. I know there's lots of cool demos that you can do, but I just feel like I haven't brought it into the rest of what I'm teaching. It's like moles, and then PV equals NRT, and then gas laws.
Yeah.
Or gas laws, and then PV equals NRT, and then I feel like I haven't really. Maybe it's I need to get talking to a physics colleague. I can do the demos and we can look at the relationships, but I can't really enjoy it.
Yeah.
The other one is, like I said earlier, I've focused on synthetic organic chemistry when I was an undergraduate. So organic chemistry I love, but I always teach it at the end. So I'm always rushing, and I have never taught it the way I'd like to.
Yeah.
And so it's not the topic itself that I dislike. Obviously, I love organic chemistry, but it's just the teaching of it has never been satisfactory to me. And then there's the odd thing in the guide, like acid deposition in the old guide, that I was like, okay.
Yeah, okay,
let's try
rattle
and
through this.
Incorporate this rather than just go through the list.
Yeah, okay, interesting. Second one, what's your most memorable demo or practical failure?
Okay, so I tell my students about this. It was my first year teaching, and we were doing gas tests as a GCSE class, and we were doing gas tests, and you'll use splints, and somebody put a glowing splint in the bin. So we finished talking, we'd finished the practical, we were just discussing something, I don't know, doing a write-up or something. And all of a sudden, I turned around and saw the bin was on fire, and it was a plastic bin, one of those cylindrical plastic bins that were on fire. It was starting to melt.
Oh, God, yeah.
And it was right in front of the door, and this was really good for the operations people later to know. I was like, the fire extinguisher needs to be moved, because it was right on the other side of the room, and I couldn't get to it because I had so many students in the room. It was just a moment where I just thought, how am I going to solve this? How can I couldn't get them out? So and they were really impressed, because I took a heat-proof mat and just put it on top. It was a really simple solution. Put it on top of the bin, and of course that then drowned the fire. And then I was like, yeah, I'm totally cool with it, and started talking about the fire triangle and all of this.
Oh, look at that, just making it a teachable moment. That's totally, admirable, yeah. Elisa. That's really admirable.
Awful. Yeah, anyway, so never put a glowing splint in the bin.
Yeah, that's a good combination of both blocking your fire exit and being as far as possible from the safety. I mean, in my head, I'm running for that fire extinguisher just for an excuse to start spraying that. I've never actually used one in kind of
no, not
with
in
need.
teaching.
No.
I guess, and then all the plastic, like I said, the bin was made of plastic, so all those fumes, and it was really bad. Really bad.
Yeah, I mean, it's the kind of thing that has the potential to have gone quite a lot worse as well, had you not have noticed that quite quickly.
Exactly, yeah, I think so. I think that was it.
I like that. And okay, last question then. Who have you learned most from?
Okay.
In the context of becoming a better teacher?
Well, I mean, obviously the students, mostly. I think they've taught me everything I know about teaching, almost everything I know about teaching, and colleagues, like I mentioned earlier. And that collaboration doesn't have to be my department or a group of teachers in a workshop, or the PRC or the program communities. It's all of those things, things like this podcast, for example. Now, I've been in schools where I've been the only chemistry teacher, and that's really hard. So I've really kind of found some people that I really, really learn a lot from, that I, follow on what used to be Twitter or whatever. Now I follow their blogs. One of them is Nikki Kaiser, who's a teacher in the UK. She's a teacher researcher, I think. And she's a chemistry teacher. She does a lot of work on bonding and misconceptions around bonding. Keith Tabor, who's a professor at the University of Cambridge in science education. Right. I first became aware of his work because he worked with the Royal Society of Chemistry to write this book about chemistry misconceptions, maybe it's like chemistry misconceptions. And that was in the early 2000s, I think. And so that's when I first became aware of Tabor, and he's got a blog that's really good, and you can subscribe to his mailing list, and he's always got really interesting questions to think about. And then in the curriculum review, when we were going through the stuff on conceptual understanding, we drew heavily on some of his work on that, because he's written a book on the nature of the it's called The Nature of the Chemical Concept. And so a lot of the idea, that the foundational ideas behind the linking questions being introduced in the guide, and this slightly different take on conceptual understanding from the Erickson model that's usually used in IB publications, it was mostly drawing on Tabor's work. So big name for me there. The other one is Bob Worley, who, I don't know if he used to work for Cleeps or he works for Cleeps, but his thing is the microscale stuff. You're nodding, so I hear you.
He came to my previous school and ran a workshop on microscale chemistry. Yeah.
So I just love his microscale stuff. It really, thinking about the IA, for example, when you think about ethical and environmental considerations, do students need to be using 500 milliliters of some of these solutions, for example, and getting them to do microscale reactions and make microscale experiments is always really good for them to kind of relieve extraneous cognitive load, but it's also really good for the department budget, and it's also better for the environment. It's amazing. That must have been a really good PD.
Yeah, it was. And actually, aside from all of that, it's quite cool to do these little there's electrolysis in a Petri dish. There's some really cool things that the students, it's quite novel for them to be doing things and there's really small scales. I think, there's a list of great people there. And I think that the Royal Society of Chemistry Misconceptions book I've got printed off somewhere in a cupboard from way back when, which I think is brilliant. So there's a few names there I need to check out, and a couple of books by the sound of things. But Elisa, thanks so much for your time. It's been a real joy having you on. Someone of your experience in just all areas of the IB has a lot of value, and clearly in the work you're doing, people are getting to see some of the value. So I appreciate you taking the time to talk to me. There's a million other things that maybe we can talk about at a future occasion at some point. But thanks very much for being on the podcast. And,
thank you so much for having me. This has been really, really nice. I will be in touch when I do my IAs for sure. And I'd love to talk about TOK and chemistry and some of your areas of expertise. But it's been really, really nice initiative. So I'll be following the podcast with interest.
Great, thank you. I'll put the light.
Thanks for having me.
Yeah, great. It's been great having you, and I'll try and sort out the lighting for next time. It's been a real kind of mixed bag on my end, but for your setup seems nice and stable. So
I don't know.
Thanks very much, and hopefully speak to you or see you again sometime soon.
Yeah, that'd be great. Thank you. Bye.